Yeah, good evening. You're learning general purpose implementations. How many classes are there general purpose implementations? 10. What is first one? Array list. Array list is completed. Okay. Second one, linked list. Third one, has said. Fourth one, linked as said. Fifth one, tree said. Sixth one, hash map. Seventh one, linked hash map. Eighth one, tree map. Ninth one, priority queue. 10th one, array deck. Okay. 10. Are these generic classes? Are these generic classes? Yes. That is like this. You know, it is also E means element. Okay. It is K comma V. K means key. V means tree map. Also K comma V. Like E. Here E. Okay. Now here array list class is completed. Array list is studied. Linked list required. Next node. Second one, linked list. Second one, linked list. Second one, linked list. You have seen array list. What is array list? Resizable array, array representation of list implementation class. This all you study, no? Linear list data structure here. It is an implementation of double linked list data structure. Double linked list data structure. It is an implementation of double linked list data structure. It is an implementation of double linked list data structure. It is an implementation of double linked list data structure. See, linked list nothing but it is an implementation of double linked list data structure. What is double linked list required? I'll explain. Before that, it is one more definition. It is a linked representation of list implementation class. It is a linked representation of list implementation class. It is a linked representation of list implementation class. See, this is also right answer. This is also right answer. Okay. It is also right answer. It is also right answer. Next. It allows duplicate elements. It allows duplicate elements because it implements list interface. It allows duplicate elements because it implements list interface. It allows duplicate elements because it implements list interface. It allows duplicate elements because it implements list interface. List interface allows duplicates. That is the reason array list also allows duplicate, linked list also allows duplicate. Next, it allows null values also. It allows null values also. It allows null values also. It occupies more memory because data stored in nodes. It occupies more memory because data stored in nodes. It occupies more memory because data stored in nodes. What is node? I'll explain. Here, each node contains three parts. Here, each node contains three parts. First one, left link field. Second one, data field. Third one, right link field. Here, each node contains three parts. First one, left link field. Second one, data field. Third one, right link field. Left link field contains previous node address. Data field contains data. And right link field contains next node address. Left link field contains previous node address. Data field contains data. And right link field contains next node address. Left link field contains previous node address. Data field contains data. And right link field contains next node address. This is, if you see diagrams, if you see program, you'll get a clarity. Here, left link field. Here, data field. Here, right link field. Here, previous node address. Here, data. Here, next node address. Node. Previous node address. Here, data. Here, next node address. Left link field, data field, right link field. Previous node address, data, next node address. See, why it is called linked list? This type of nodes connected together as a list. That's what it is called linked list. This all how it is connected with the previous node address, next node address, previous node address, next node address, connected. That's what it is called linked list. So this type of nodes all connected together as a list format. That's what linked list. How these all connected? With addresses. That's what linked list. With diagrams, you'll get a more clarity. After program, I'll give diagram. Like left link field, data field, right link field. 3 parts for every node. Previous node address, data, here next node address. This is node diagram. This is just node. It is node diagram. Okay. But writing program is same. There is no change. Internally different. Is it over? It is node diagram. See. Program I'll show you. You observe here. Linked list. Integer. LL equal to new linked list. Same. Array list you studied, no? Like that only. LL dot add one number. LL dot add one more number. LL dot add one more number. See, like this you can add. System dot out dot println LL. Now, file, save. Java C demo.java. Java demo. See, are you getting any difference? Array list, linked list? No difference. Okay. Array list program also you are writing like this only. Linked list program also you are writing like this only. Just name only. Here array list, here linked list. Writing program style is same. Say array list only 5-6 programs are given. Like first homogeneous, next heterogeneous, duplicates, and iterating with enhanced for loop, and set method, get method. Like this, 5-6 examples are given. Same examples with linked list also you can write. But what is the difference between array list, linked list is interview question. Same. Now as it is here, what are the programs you have seen? Just array list place linked list write. Program writing is same. Output also same. No change. Whatever the outputs you have seen for previous programs, same output comes. But what's the difference between array list, linked list? I'll explain. First you write this program example. Example, write this program. Is it over? See. Is it over, all people? See. Array list you studied. Like that only. Linked list. Java.util.linked list. Java API documentation, latest version 18. In this documentation, first modules appears, base module. In the base module, util package. See, util. In the util package, classes, linked list. Alphabetical order will be there. Linked list. See, double linked list implementation of list and deck interface. One more interface also implemented. Double-ended queue interface. See, here superclass, we can find out. See, here constructs an empty list. Constructs a list containing that elements. If you pass elements with collection interface, it is passed. But it is empty list. Capacity we cannot specify. No capacity, no load factor. If one element comes, one allocated, one only stored. Second element comes, second only allocated, stored. That's what? No initial capacity, no load factor. Initial capacity, nothing but 0. Okay? Depends upon that, added. So, here no initial capacity, no load factor. Now, same methods you observe. Here also, but only additional methods, add first, add last, like remove first, remove last, get first, get last. These methods are additional. Now, I'll explain with the diagram, you'll get a more clarity. First, array list, linked list difference with the diagram I'll explain. After that, notes I'll give. Suppose, array list, integer, don't write, just listen, equal to new array list. Let's will write al dot add one number. Al dot add one more number. Al dot add 1 comma 83. System dot out dot println al. What is the output comes? 98, 83, 55. Clear no? Any doubt is there? Say, initially, how many elements memory allocated? 10. Data shuffled. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Say 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Now, this is array list object created initially. Like this created. Array list object created. This array list object referred by AL. Referred by AL. Okay. So initially, when first line is executed, 10 elements memory allocated. Okay. 10 elements memory allocated. Index starts with 0, ends with 10 minus 1, 9. Okay. EL dot add 98. Where it is added? 0 location. So here added. Next AL dot 55, one place. But already one place 55 is there. 1 comma 83 means, is it modified? Is it modified? Data shuffled. So it will be shifted here. Okay. 55. Now it will become 83. Data shuffled like this. If I print, output comes 98, 83, 55. Now, just in the place of array list, if I write linked list, then also same output. But internally, lot of difference is there. What is the difference? I'll show you. When we have to use the array list, when we have to use linked list, I'll explain after the diagram. First write this one. Array list. It is called index. It is called element. In this diagram, any doubt is there? It is already explained. Now linked list I have to explain. Okay. So this is array list. First, what will happen when first line is executed? Whenever first line is executed, 10 elements memory allocated. Index starts with 0, ends with 10 minus 1, 9. Okay. When you add element, added at the end only. So 0 place added. Next 1 place added. Next it is going to add 2 place, but I specified index. That's what data shuffled. Suppose if I write AL dot add 0, 20, if I write, what will happen? The 55 shifted to 3 place. 83 shifted to 2 place. 98 shifted to 1 place. 20 added in 0 place. Data shuffled. Suppose 1000 elements are there. 1000 times shuffled. But shuffling is not easy. Burden to processor. System performance will decrease. 1000 elements are there. 0 place will add. 1000 times shifted like this. Shuffled. Shuffling burden to system. Burden to processor. That's what linked list. But linked list also drawback is there. More memory. For every element, three parts required. Okay. See. That diagram I'll explain. But in this program, in this diagram, any doubt is there? No. See, but linked list, listen with more concentration. Okay, linked list, you concentrate. Now, linked list you observe. Linked list, integer, LL equal to new linked list. If I write, first what will be happen? See, if you write like this, same what I given first what is the number? 98. Second number 55. Third 1,83. Now you observe system.out.println LL. Output is same, there is no change, but internally what will be happen? See. Okay, I'll change the color. Now you observe. See, linked list object created. Linked list object created. In that object, so object created like this. First, last. It will be null. It is also null. Initially like this. You observe linked list LL equal to new linked list. If you add very first time, when first line executed, memory allocated like this. Okay, linked list object created. In that object, first last two parts created. First part contains null, last part contains null. That means if first node is there, first node address. Last node is there, last node address. But now present nodes are not there. That's what null. When first line executed, what will happen? See, when first line executed, this is that whatever I given there, that is outside I am writing. First, last. It is null. Now 98 purpose, one node created. 98. One node created. Now 98 purpose, one node created. You already studied. Each node has three parts. First part is called left link field. Second part is called data field. Third part is called right link field. Left link field, what it contains? Previous node address. That is only first node. That is only first node means there is no previous node. So it will be null. Data field, data. Next, right link field contains next node address. That is only last node. That is only first node. That is only last node. So null. Now what will be happen is here this node address placed here. Now it is modified. This node address placed here. Here also it is modified. This is only last node. Like this, links created. So this is only first node. First node address placed in first. This is only last node. Last node address placed in last. First contains first node address. Last contains last node address. Here there is only one node. That is only first. That is only last. So same address placed in both the places. Like this constructed. When second line LL dot add 55, third line, then what will happen is again created. Now suppose. Now first as it is, I'll write as it is. As it is, I'll write. It is first. It is last. Year, null, 98, null. Whatever is there, that is I am writing. Now, whatever I given here, that is only written here as it is. After this, LL dot add 55. Then one more node created. So one more node created now. Node created here. 3 parts. 3 parts. Now that node, 3 parts. First part is left link field. What it contains? Previous node address. For this previous node is this one only, no? So this node address placed here. So orange color node is there, no? That node address placed in yellow left link field. Here data. What is data? 55. Here what will be there? Think yourself. Next node address. Next node is there? No. Then what will happen? Null. But here what will be there? Next node address. Now next node is this one, no? It is modified. Now this node address placed here. Now which is last? Orange color or yellow color? Yellow color. So this link broken. Like this placed. Now orange color node is first node address, first node. Yellow color is last node. Now this one as it is, I'll write. This one first as it is, I'll write. This one as it is, I'll write first of all. You observe. That is null. Year 98. Year 55. Year null. Okay. Now you observe. It is first. It is first. It is last. Now LL dot add 1 comma 83. LL dot add 1 comma 83. That means between these two nodes inserted, no? So what will be happen is one node created. One node created. Here 3 parts. First data field, I'll place 83. 83 I'll place. Now these links are broken. These links are broken because in between it has to insert. So it contains next node. That means this address. It contains this node. like this. Now it contains this node. Now it contains this node. Here, is it data shuffled? No, without shuffling. Without shuffling, allocated. Now what will happen? See here, first started here. Actually, this one started. It contains this object address. This contains object address. So it comes here. In that first, which contains first node address, control comes here. It will print 98. Here next node address, it comes here. It will print 83. Here next node address, it comes here. 55 printed. Next not there. Stopped. Reverse. Here last node address, it comes here. 55 printed. Previous node, it comes here. 83 printed. Previous node, it comes here. 98 printed. Null. Stopped. So forward direction iterating, backward direction iterating possible. But here the main difference between array list, linked list. Here data not shuffled. Suppose 1000 elements are there in order. 0 place I want to add. What will happen here? Suppose before 98 I want to add. What will happen? One more node created. This link broken. That is placed here. This address placed here. Data not shuffled. So without shuffling of data, element can be inserted, element can be removed without shuffling. But it will occupy more space. See, each element 3 parts. If 1000 elements is there, 1000 into 3, 3000 parts memory. But there 1000 only. Here triple. So if you think about RAM, this that is better. If you think about processor, this is better. That's the reason. Depends upon application requirement, they'll select. Performance point of view, if they think linked list highest performance. Memory point of view, think array list is better. Depends upon situation. There also advantage is there. Here also advantage. There also disadvantage. Here also disadvantage. So depends upon situation. Depends upon situation, we are going to select. Okay? Write this one, linked list. I'll give differences. Write the diagrams all. Understood? Any doubt is there in this diagram? Any doubt in this diagram? Once again. Okay, 1 minute. Okay, first note down. First complete. Over. So array list, linked list, writing program style is same, but internally lot of difference. Internally totally different. But program no change. Only array list plus linked list name. Name only changed. Remaining all same. But internally lot of difference is there between array list and linked list. That is array representation. This is linked representation. These are links only, no? Suppose if it is C language, these all you have to create. There is no linked list library. We have to write. Like this, links also we have to create. One node structure we have to create. With that node, 3 variables you have to create. Like that. But here, built-in class is there, very simple in Java. The creating links and inserting links in diagrammatically easy. Programmatically, okay, diagrammatically you can insert anywhere, but programmatically not easy. But in Java very easy because already written logic. I'm not writing any logic inbuilt. Java very simple. If it is C language, you need to write first a node structure. That node pointers you have to create. With pointers only possible. Is it over? See, I'll explain. See, I'll explain. See here. First of all, this line executed. When this line is executed, empty linked list created. Empty. Nothing is there. Only these pointers, references created. First contains null. Last contains null. Actually, first contains first node address. Last contains last node address. But there is no first node, there is no last node. Initial capacity 0 here. No memory. That's what. First contains null, last contains null. This is a part of linked list object. This is referred by LL. So when this line is executed, like this created. Okay. After that, whenever you add one element, for every element, one node created. So this is node. This is node created. This node contains 3 parts. Left link field, data field, right link field. Left link field contains previous node address. But this is only first node. There is no previous. This is only first node. There is no previous. That's what null. Data field contains data. 98 placed here. Right link field contains next node address. But this is only last. Next is not there. That's what null. This is only first node. This is only last node. That's what this node address placed here. This node address only placed here. So it is only first node. It is only last node. Like this, same node address placed in first place. Same node address placed in last place. Okay. Now after that, next line. When this line executed, 55. First, this is as it is a written orange color. This is only as it is a written orange color. After that, when I add 55, one more node created. That is yellow color I given. Yellow color. Here, it contains previous node address. So before this, already one node is there. That node address. So this orange color node address placed here. Data 55. Next node is not there. That's what null. Now Orange color is first node. Yellow color is last node. That's what this link broken. This link created. Like this. Now, when third line executed, we have to insert between these two yellow nodes. Okay. It is first node, it is last node. But in between, we are going to insert 1, 83. It is 0, it is 1, it is 2. That's what here we have to insert. Then what will happen? These two, one more node created. These two links are broken. New links are created. New links are created. So control here, this contains this node address. This one contains this node address. Now, like this, node inserted with new links. Data not shuffled. Now, iterating how it is possible, see, it contains first node address. It comes here, 98 printed. It contains next node address. It comes here, 83 printed. It contains previous next node address. It comes here, 55 printed. Null, stop it. Reverse also. From here it comes here, 55 printed. Previous node address, 83 printed. Previous node address, 98 printed. Null, stop it. So internally like this. Okay. Here data not shuffled. Even 1000 elements also, at the beginning also you can add, at the end also you can add, middle also you can add, anywhere you can add. Without shuffling of data we can add. Without, now suppose, even if you want to delete, suppose this element if you want to delete, this element you have to delete. You can delete. Now this node address placed here. This node deleted. This node address placed here. Here it will be null. This link also broken. So very simple. Now write it. Array list versus linked list. Array list versus linked list. One side array list, one more side linked list. Array list versus linked list. One side array list, one more side linked list. Array list versus linked list. One side array list, one side linked list. First one, here. It is an array representation of list implementation class. It is a linked representation of list implementation class. It is an array representation of list implementation class. It is a linked representation of list implementation class. You have seen array representation, array diagram, linked list diagram. Links are there, no? All nodes linked together with the previous node, next node, previous node, next node. Links are there. So in both the cases, list interface implemented. Okay. In both the cases, list interface implemented. But it is array representation, it is linked representation. That is first difference. Okay. Next. It occupies less memory. It occupies more memory because data stored in nodes. It occupies less memory. It occupies more memory because data stored in nodes. Because every node 3 parts. That's what triple memory. Triple memory required. If 1000 elements are there, here 1000 only required. 1000 slots. There 3000 slots. Triple memory. In array list, insertion and deletion operations require shuffling of data. In array list, insertion and deletion operations require shuffling of data. In array list, insertion and deletion operations require shuffling of data. If you insert also shuffle, if you delete also shuffle. See, 1000 elements are there. First place you want to add, like this, shuffle. First element if you delete, reverse shuffle. Reverse also shuffle. So first to the last shuffle or last to the first, like this also reverse also shuffle. Insert time, delete time, shuffle. Here. In linked list, it does not require shuffling. In linked list, it does not require shuffling of data. In linked list, it does not require shuffling of data. Fourth one. It is an implementation of linear list data structure. So in a data structure, this concept is called linear list data structure. It is an implementation of double linked list data structure. It is an implementation of linear list data structure. It is an implementation of double linked list data structure. See, in array list, adding employee details and string details, string type data, integer type data, different types are given. Same programs with linked list, you can do it, nothing. Okay. But additional methods we have, see, Java P. Okay, already it's documentation open. No? Here. You observe these methods additional. Add first, adding at the beginning. Add last, adding at the end. Get first, getting first element. Get last, getting last element. Remove first, remove last. Because both sides possible. That's what this type of methods are there. Additional methods. Only add first, remove first, get first, get last. These methods are additional. Remaining all same. Remaining whatever is there in the array list, that is, this is same. These are the differences between array list, linked list. Is it clear? Just general purpose implementation, 10 classes are there. Only 2 classes completed. Only 2 completed. Still 8 classes are there. Okay. That is, we'll see next class. Tomorrow is a holiday. So tomorrow no class. We'll see continuation on Wednesday. Okay. Wednesday, we'll see continuation. Tomorrow is a holiday. Day after tomorrow, we'll see continuation. Online student, any doubts are there, online students? Just 1 minute. Any doubts are there, online students? No doubts? Okay, we'll see continuation on Wednesday. Tomorrow holiday, day after tomorrow we'll see continuation.